So with question 16, here's what we have. How much does Mr. Wa spend on rent? So when you look at rent, we have this sign over there. It looks like this. That's how it looks like, something like this. And this is 90 degrees, okay? That sign means that the angle over there is 90 degrees. So to find the amount of money he spent on rent, it is going to be the angle for the rent, which is 90 degrees, out of the total sectorial angle, 360 degrees, multiplied by his monthly income. And then the monthly income is 18,000 cedis. Divide here by 10, this 0 is gone. Divide here by 10, this 0 is gone. Divide here by 9, you have 1. 9 will divide 36 4 times. So now you have 1 out of 4 times 18,000 cedis. And this will be equal to 1 multiplies 18,000 cedis. You have 18,000 cedis all over 4. And this will give us, let's see, 4 divides 18. 4 times. 4 divides this 18. 4 times. There will be a remainder of 2. Alright? When you bring the 2 here in front of the 0, you have, so the remainder 2 here, and then this 0, you have 20. 4 divides the 20, and then you have 5. So these 3 have been divided, then you have 2 zeros left. 0.00. Alright? Let me take it back. So if we are supposed to use the long division, this is how we go about it. Okay? 18,000. 4 divides 18 is 4. 4 multiplies 4, you have 16. The difference will give you 2. You add this 0, 4 will divide 20, and then you have 5. Alright? When you have 2 zeros left, so you just add the 2 zeros, and that's it. 4,500. Alright? So the amount of money Mr. Wa spent on the rent is 4,500 cedis. That's what we have over here, and we are done for that. So question 16 has been solved. Let's box on, have a look at question 17. So with question 17, the question will be displayed on the screen, and question 17 demands that we find the size of the angle representing savings. When you take a look at the pie chart, all the other monthly expenditure that we have over here, when you take a look at them, they all have their sectorial angles with the exception of savings. So savings doesn't have any sectorial angle, so we need to calculate for that. So we'll add the angles for all the other expenditure that we have over here. All right, add all their sectorial angles and then subtract it from a total of 360 degrees. So that's how we solve question 17. So it's gonna be 360 degrees minus the sum of the sectorial angle for food, rent, fuel, clothing. That is what we are going to do. We are going to add all of them and subtract it from 360 degrees. So for food, we have 120 degrees. We add it to that of rent. When you take rent, it's 90 degrees. When you take fuel, it's 60 degrees. And when you take clothing, it's 50 degrees. So all these added together and subtracted from 360 will give you the size of angle representing savings. So savings angle. All right, so it will be 360 degrees. Let's add 120, 90, 60, and 50 all together. So we have 120 plus 90 will give us 210, plus 60, 270, plus 50 will give us 320. It will be minus 320 degrees, and that will give us savings angle. So when we subtract 320 from 360, we have it to be 40 degrees, and that will be the savings angle. And we are done for question 17. We are done with question 17. So we can box on to question 18. We are finding the missing addend. That's what we are doing. So to find the missing addend, there is the need for us to add 245 to 1918. And then after adding that, after finding the sum, we are going to subtract the sum from 4,430. So let's find the sum of 2,045 and 1,918. Let's find the sum for those two. We have 2,045, and then we have 1,918. So we find the sum. We add these two, we have 13. We write 3, remainder 1. 4 plus 1 gives us 5 plus 1. The remainder 1 plus that remainder 1 gives us 6. 0 plus 9 gives us 9. 2 plus 1 gives us 3. So this is what we have for the sum. And then we subtract this sum from 4,430. So we write 4,430, then subtract this from it. 3,963. So let's find the difference. It's not possible here, so we borrow 1 from here, then we have 10. So 2 is left here. 10 minus 3 gives us 7. 2 is left. We can't subtract 6 from 2. So we borrow 1 from here. 3 is left here. The 1 is 10, so we add 2 to it. We have 12. 12 minus 6, we have 6. 3 is a remainder here. We can't subtract 9 from 3, so we borrow 1 from here. Then we have 13. Then 3 is left here. 13 minus 9 gives us 4. All right? 3 minus 3 will give us 0. And there is no need to write that one. So the difference is 467. That's what we have. So the missing addend is 467. If you add 467 to 2,045 and then to 1,918, you have this answer. When you add this is the missing addend. You add this to this and then to this. You have this answer. We are done for question 18. We are boxing on to look at question 19. Question 19 demands that we remove the brackets. So this is the question displayed on the screen. Let me write the question down. So this is the question that we have, and the question demands that we remove the bracket. So we have -2 multiplying everything in this bracket. So we write the A. Then -2 multiplies B. We have -2B. Now when negative multiplies negative, you have positive. So 2 multiplies 3C, then you have 6C. So removing the bracket, the final answer that we have is A minus 2B plus 6C. That's what we have finally. So we are done solving question 19. We have removed the bracket, so we are done. Let's box on and take a look at question 20. So with question 20, we are simplifying 2A out of 3 minus A minus B out of 2. That's what we are simplifying. So let's write the question down. So with this, there will be the need for us to find the LCM of 3 and 2. And finding the LCM of 3 and 2, we have 6, all right? 3 divides 6, we have 2. 2 multiplies 2A, we have 4A. 2 divides 6, we bring the minus sign over here. 2 divides 6, we have 3. Then the 3 is going to multiply A minus B in the bracket. That's what we have right now. So if we proceed, we have 4A minus -3 multiplies A, we have -3A. Then negative times negative gives you positive 3B. So 3 multiplies B, you have 3B. All right, out of 6. That's what we have right now. And boxing on, we have 4a minus 3a. So 4 minus 3 gives us 1, all right? We have a and a, they are like terms, so we can find their difference. So 4a minus 3a gives us a, that is 1a, but we write it as a. So a plus 3b out of 6. And this is the final answer to the question. 4a minus 3a is a, then plus 3b out of 6. So we are done with question 20. Let's box on and have a look at question 21. So with question 21, we are supposed to find the value of Q from this particular expression. So the question is displayed on the screen. Let me write the expression down. We have Q is equal to UT plus half FT. And from the question, we have U to be 20, T to be 10. And then we have F to be 15. So substituting all these values into the expression, we have Q to be equal to U. U is 20, and U is multiplying T. So 20 is multiplying T. T is 10. So 20 is multiplying 10. Plus half F. F is 15. And they are all multiplying together. So 15, F is 15, T is 10. So Q will be equal to 20 multiplies 10, we have 200. Plus half of 10, all right? 2 divides itself a single time. And 2 divides 10 5 times. So 1 multiplies 15 multiplies 5. So we have 15 multiplying 5. So Q will be equal to 200 plus, when 15 multiplies 5, we have it to be 75. Let's do it right here. We have 15 and 5. So 15 multiplying 5. 5, 5, 25. 5, remainder 2. 5, 1, 5 plus 2. The remainder 2, 7. So 75. So now Q will be equal to 200 plus 75, which is 275. And that is the value of Q. So we are done calculating the value of Q after substituting all these values into the expression. The final answer is Q is equal to 275. So we are done with question 21. Let's box on to question 22. With question 22, the question will be displayed on the screen. And there's what we have. We have 3 out of 15, and it is equivalent to 45 out of A. With this particular question, it falls under equivalent fractions, all right? Equivalent fractions. So let's see how best we can solve this. When you have a question like this, 2 different common fractions equated like this, all right, it means that you just have to cross multiply to find the value of A. That's what we do. Or you find the common factor that was multiplied by 3 to obtain 45, and then you multiply this also by the same common factor to obtain the answer over here, all right? But the best way is for us to cross multiply and then find the value of the variable A. So we cross multiply, 3 will multiply A, and then 15 will multiply 45. So 3 multiplies A, and we equate it to 15 multiplying 45. So 3 multiplies A, we have 3A, and then 15 multiplies 45. I won't find the product. I will just write them just as they are. And let me rewrite the whole thing again over here. So to find the value of A, we divide here by the coefficient of A, which is 3. Divide here also by the same 3, all right? So 3 divides 3, you have only A remaining. And then when 3 divides itself a single time, it divides 45 15 times. So we have 15 multiplying 15. So when 15 multiplies 15, what will be the product? Let's bring it up here. 15 multiplying 15. 5, 5, 25. We write 5, remember 2. 5, 1. 5 plus 2, 7. 1 multiplies 5. We have 5. 1 multiplies 1. We have 1. We find the sum over here. We have 5. 7 plus 5. 12. We write 2, remember 1. 1 plus 1. We have 2. So it is 225. So when 15 multiplies 15, we have it to be 225. And that is the value of A. Alright? So over here, from here, you could see that they multiplied 3 by a particular factor. Okay? And the factor is 15. And then they obtained 45. So it means we have to multiply this same 15 by that same factor, which is 15. The one they used to multiply the 3 to obtain the 45. So if you multiply 15 by 15, then you have 225. And that is the final answer to question 22. So we are done with question 22. Let's box on to question 23. All right, so with question 23, the question will be displayed on the screen, and the question is related to LCM. So we are finding the least common multiple of 7, 14, and then 18. So let's do that. For us to do this, we've got to rule some lines over here. So 1, so let's write down the numbers that we are finding their LCM. We have 7, 14, and then 18. We are finding their LCM. So this is how we go about it. Okay. We are going to divide all these numbers using prime numbers. So we are dividing these numbers over here using prime numbers. And the prime numbers start from 2, 3, 5, 7. 9 is not part of the prime numbers. 11 is part. 13 is part. 15 is not part. All right. 17 is part. 19 is part. So we are going to divide all these numbers using prime numbers. Now, if the prime number can divide one of these numbers, you are good to go. You can go ahead and use that prime number to divide it. Are we following? So once it can divide one of them, we are good to go. We can still use the prime number. But over here, the prime number that I will use is 7, because 7 can divide 7 and 14, though that 7 can't divide 18 equally. It can divide this and that, so we can go on and use the 7. I write down the 7 over here. 7 divides 7, we have 1. 7 divides 14, we have 2. 7 can't divide 18 equally, so I'll have to repeat the 18 over here because 7 can't divide it equally. So when I come down here, we have 1, 2, and then 18. 2 can divide 2 and 18, and 2 is a prime number, so I can use 2 to divide these. Over here, 1 can't be divided by 2. So we write the 1 down. When 2 divides 1, it's not possible. So repeat the 1 here. 2 divides 2, you have 1. When 2 divides 2, you have 1. 2 divides 18, then you have 9. Now you have 1, 1, and 9. What prime number can divide 9? 3 is the prime number that can divide 9. 3 can't divide 1, so just write the 1 there. 3 can't divide 1, so write the 1 there. 3 divides 9, you have 3. Again, what prime number can you use to divide these? Still, we maintain the 3. 3 divides 1 is not possible, so write the 1 there. 3 divides 1, not possible, write the 1 there. 3 divides 3, then you have it to be 1. When you get to the point where all the numbers that you are dividing appear to be 1 in each of the cases, then it means that you are done with the division. All right. Once you are done with the division, just write down the prime numbers you use to divide the numbers over here, all the prime numbers here. All right. For us not to waste time, let's multiply all of them. So the LCM is going to be 7 multiplied by 2 multiplied by 3 multiplied by 3. We multiply all of them. 7 2 will give us 14 multiplied by 3 3 will give us 9. So 14 multiplied by 9. 4 9 will give us 36. So we write 6 remainder 3. 9 1 will give us 9 plus 3 will give us 12. So 126. So the LCM for 7, 14, and 18 will be 126. And we are done for question 23. So let's write down the length that we've been given, the lengths that we've been given from the question. So this is what we have. We have the length xz, which is equal to 13 centimeters. And then we have another length xy, which is equal to 12 centimeters. So now there will be the need for us to find the length YZ. We've been given the area of the triangle as well. So the area of the triangle is 30 centimeters squared. So 30 centimeters squared. Now, with the right-angled triangle, we have two lengths given, and we need to find one of the lengths. So once we've been given the area of the triangle, it means you will go by the formula of area of a triangle and then use that one to find the length YZ. So with the area of a triangle, so area of a triangle, the formula is given by half times the base of the triangle times the height of that same triangle. The area of a triangle is given by the formula half times the base times the height of that same triangle. So over here, we will need to substitute the area of the triangle, which is 30 centimeters squared, into the formula. So let's come up here, up over here. This is what we have. The base of the triangle is not known. All right, and the base of the triangle is equal to the length of YZ. That is what the question is demanding that we find. So we are finding the length of YZ. That is what we are calculating for. And then over here, up here, the length YZ. YZ is the base of the triangle, and that is what we are solving for, the base of the triangle. We have the height of the triangle to be xy. So xy over here is the height of the triangle. So xy is also representing the height, which is h of the triangle. And that one measures 12 centimeters. So we are calculating for the base, of which we don't know the value or the length. We know the height of the triangle xy to be 12 centimeters. And we have the area of the triangle to be 30 centimeters squared. So let's just substitute all these values into the formula. So the area of the triangle is 30 centimeters squared. We put that one down. And then we have the formula to be half multiplied by the base. And the base is what we have here. The base is YZ. Okay, that is the base, the length YZ. Multiplied by the height. Now the height is 12 centimeters. So we can find half of 12 centimeters, right? So 2 divides itself a single time, divides 12 6 times. So 30 centimeters squared is equal to, over here we have 1 multiplying YZ multiplying 6. So when 1 multiplies 6, you have 6. So we have YZ over here, the length of YZ, multiplying 6, because when 1 multiplies 6, you have it to be 6 centimeters. Let's rewrite this whole thing again. 30 centimeters squared is equal to the length of YZ multiplied by 6 centimeters. So this is it. We are calculating for the length of YZ, which is the base of the triangle. And for us to be able to calculate for the base of the triangle, which is the length of YZ, we need to divide here by 6. We need to find YZ. So we have to get rid of 6 centimeters from here. For that to happen, we divide here by 6 centimeters. We divide this side by the same 6 centimeters. What you do at the right hand side, you make sure you do same at the left hand side. So over here 6 divides 6, and that is gone. Now we have YZ left. So let's continue from here. The length YZ will give us, now when 30 is divided by 6, you have it to be 5. All right. And then since we are calculating for length, it will be in centimeters. Bear in mind that it will be in centimeters. So the length of the base of the triangle, which is YZ, is 5 centimeters. So our question 24 has been solved. Let's box on, take a look at question 25. We are moving on to question 25, and the question will be displayed on the screen. So with question 25, this is how we go about it. We are converting a particular value. We have 1204 base 5. We are converting that to base 10. So this is what we do. Let's write the number down. This is what we have, 1204 base 5, and we are converting this to base 10. So the base is 5. So this is how we convert it to base 10. You take each of the values over here and multiply it by 5 with the powers of that particular base. Okay, so when you take 1, multiply it by 5, and then it takes a power. But we begin from the right hand side to the left. The powers of 5 will increase from the right hand side to the left. So let's begin and let's see how we do this. So this is it. And so we take 1 and multiply it by 5, plus take the 2, multiply it by the base 5, add it to take 0, multiply it by the base 5, take 4, multiply it by the base 5, and then since 4 is the last number, with the base that we have written over here, the powers will increase beginning from the right hand side to the left. So we begin with the powers of the base, writing or starting from 0. Then here, the base will take a power of 1, the base will take a power of 2, and then the base will take a power of 3. Good. Once we are done, we find the answer to the base and the powers that we have over here, and then we multiply the answer by the other numbers we have in the brackets. Okay, so boxing on, we have 1 multiplied by 5 raised to the power 3 will give us 125. 5 raised to the power 3 means we have 5 times 5 times 5. 5 is 25. 25 times 5 give us 125. Plus 2 multiplying 5 squared will give us 25. Plus 0 multiplied by 5 exponent 1 gives us 5. Plus 4 multiplied by 5 exponent 0 gives us 1. So this is what we have. 1 multiplies 125, we have 125. 2 multiplies 25, we have 50. 0 multiplies 5, we have 0. 4 multiplies 1, we have 4. So this is it. We sum up all these. So 125 plus 50 gives us 175. 175 plus 0 gives us the same answer, 175. 175 plus 4 gives us 179. And that is the final answer to this particular question, 179. So converting 1204 base 5 to base 10 gives us 179. And that is the final answer to our question 25. We now box on to question 26.